Hi everyone, this is Miss Cress, and I'm going to go through the notes with you on moles. Now remember, this is our second unit for math, so this is going to have some math problems in it. So at the end, you are going to need a calculator and also your periodic table. So if you don't have that right now, please make sure that you go get that, pause the video, and then come back. So, for example, as you remember in our last unit of math, we have dimensional analysis, or that crisscrossing thing that we did with the fence posts. So here's a basic example that we did before. 4 days equals how many seconds? Well, down here you have your conversion factors. We know that 1 day is equal to 24 hours, 1 hour is equal to 60 minutes, and 1 minute is equal to 60 seconds. So we start with what we have, which is 4 days, and we go diagonal and say, all right, we need to cancel out days, so we put days on the bottom. If we use days, we come down here and we see, okay, 1 day is equal to 24 hours, so hours has to go on the top. We have to get rid of hours, so we put it diagonally on the next conversion factor, and then minutes on the top because we're going down. Again, we don't want to stop at minutes, so we put minutes on the bottom and seconds on the top. Now notice, again, I didn't put any numbers in. I just put my units. So now I'm going to go through and I'm going to make sure that I'm at the unit that I want to end at, which is seconds. And now I get to put in all my numbers that are associated with each one of these conversion factors. Once you have all the numbers in, you multiply everything on the top, multiply everything on the bottom, and then divide the top by the bottom. Remember, we're just making one gigantic fraction here. And so you're going to end up with 345,600 seconds. So here's a similar problem. Again, we're crossing out our units. We figure out we get to days. From our conversion factors, we fill in the numbers. Multiply the top, multiply the bottom, divide the top by the bottom, and you get 3 days. So what is a mole? Well, a mole is a really, really, really big number, and it explains how many atoms are in any given substance that you have. So I know it's a little confusing, so let's talk about what we do know right now. What we do know is what atomic mass is. And back at the beginning of the first math unit, we talked about atomic mass. And atomic mass is the collection of as many atoms as you have in a given compound, and then you are averaging that weight together. So that is going to be, if you're talking about an element, let's say hydrogen has 3 isotopes. The first isotope is 10% abundant in nature. The second one is 15% abundant in nature, and the third one is 75% abundant in nature. Now, on average then, you would figure out what the average isotope is, and then that is what is put on the bottom of the periodic table in hydrogen's little box. And remember that those atomic masses are measured in atomic mass units, which we call AMUs. So, when we talk about the average atomic mass, we usually say AMUs, but if we pile up enough of that atomic mass, so let's just say for carbon here, carbon's average atomic mass is 12.011 AMU. If we would put enough carbon into a pile that would equal 12.011 grams, now notice we just changed AMU to grams, that is what we could consider a mole of carbon. So the number of atoms in that pile of carbon based off of its atomic mass is known as a mole. Now, that I have confused you, let me explain this a little bit better. So a mole is a unit that is counted just like a dozen. So you guys know what a dozen is. A dozen is 12. So a dozen eggs is 12 eggs. But also, a dozen elephants is 12 elephants. Now, why are you saying, okay, what does that matter, Miss Cress, 12 eggs and 12 elephants? Well, 12 eggs is equal to a dozen eggs, and 12 elephants is equal to a dozen elephants. They're both equal 1 dozen, but their masses are completely different. So a dozen eggs is equal to 2 pounds, but a dozen elephants is equal to about 8,000 pounds. That would be small elephants, but still, the masses are going to be different. So a mole of carbon and a mole of hydrogen, they're still considered moles. They're still considered like the word a dozen, but they have different masses associated with them. So notice, even though there are the same number of each object, 12, their masses are very different. So here's some examples again of dimensional analysis. If you want to go through them, you can. I'm not going to waste your time. I'm just going to kind of go through this. This is the setup with this. Again, more eggs. How many egg questions did I put in here? Jeez. So when we're talking about moles and we're talking about the mass of given objects or given compounds or elements, we call this stoichiometry. And the whole reason why you guys had to learn how to balance equations is to get to this point, because the big coefficient number in the front that you guys are putting in to balance your equations, that is considered 1 mole of that compound or element. I know, I just blew your minds. So 1 mole is equal to 6.022 times 10 to the 23rd atoms. It is also equal to the atomic mass, or the formula mass, in grams. And that's why you guys had to do atomic mass and formula mass for the first assignment. And we also have 1 mole is equal to 22.4 liters. Now, these 3 conversion factors are the only 3 conversion factors that you are going to be using for this unit. The only one that's going to change a little bit is this one with atomic mass and formula mass, because given the compound or the element that you're using, that number is going to change. These two, the top one with atoms and the bottom one with liters, are always going to stay the same. So honestly, I feel like this part of the math unit or math sections, this one's actually easier, because with the metric one, you had to remember how many grams are in a kilogram, how many centigrams are in a hectogram, and that kind of thing. And those were kind of hard to remember because there were so many of them, but this one, there's only 3. So I'm going to start with the easiest one, I think, which is going from moles to volume, and volume is going to be liters. So what do we know? We know that 1 mole is equal to 6.022 times 10 to the 23rd atoms. If we're using beryllium, we're going to use 1 mole is equal to the atomic mass in grams of beryllium. So if you look on your periodic table, that is going to be 9.012 grams. And then we also know that 1 mole is equal to 22.4 liters. So here we're going to volume, so we're going to need that liters one. I'm not sure why it's not popping up here. It's probably going to be at the end. Ah, there it is. It's out of order. Okay, so we have moles. We're starting with moles, and so we have to have moles on the bottom. Now we're using this conversion factor right here. So I have 1 mole here. I want to go to volume, so I put liters on the top, and then I fill in my numbers. So 1 goes with the mole always, and 22.4 liters goes with liters. Again, multiply across the top, divide by your bottom, and you're going to get 27.6 liters of beryllium. Next, we're going to go from moles to grams, and then also grams to moles. So in order to get to grams, you only have 1 conversion factor that has grams in it. So again, I'm not sure why the liters one is wait until the end, but we don't need it anyway. So we're going from moles of zinc. We have moles here. We want to cancel it out by putting it on the bottom, and then we want to go to grams of zinc. Again, how do we know this is the mass of zinc? You look on the periodic table at the atomic masses on the bottom. So 65.39 is zinc's. We fill it in, we multiply across the top, divide by the bottom, and you should get 21.19 grams of zinc. Hey, look at that. Came in last. I need to fix that. Okay, so here's another one. Instead of going from moles to grams, it's grams to moles. So if you start with grams, you have to cancel it out with grams and then put moles on the top. And pretty simple. that liter is always at the bottom. All right, I'm just going to go through this. You guys can go back to the original PowerPoint and check it out yourself and go a little bit slower if you want to. But I want to get to the last one with atoms here. So we've already used liters. We've already used the one with atomic mass or formula mass. And now we're going to go to atoms. Here it is. So what do we know? We're going to use this conversion factor. 1 mole is equal to 6.022 times 10 to the 23rd atoms. And how do I know that? Because I have atoms up here and I want to go to moles. So if I start with moles, I need to cancel out with if I start with atoms, I need to cancel it out with atoms. And if I have atoms on the bottom, that means I have to have moles on the top. I'm going to fill in my numbers. So 6.022 times 10 to the 23rd goes on the bottom and 1 mole goes on the top. So if you do this, you can do it on a graphing calculator and get this answer, 0.206 mole. Right now, I really don't care that it's not in scientific notation, but if you really want to stick with scientific notation, I have that here on the bottom. So here's my shortcut that I taught you all how to do. You take the coefficients and do the math. So this would be 1.24 divided by 6.022, and you're going to get, hey, 0.206. Then you're going to have to take your exponents, so to the 23rd, so 23, and remember, because we're dividing, that's like a giant subtraction sign, so 23 minus 23 is going to be 0. So honestly, if you wanted to put it into scientific notation, you could. This would be 2.06 times 10 to the negative 1 mole, but honestly, I really don't care right now. So that is it for your examples. And again, go back through here, look at some YouTube videos, and then try to do your molar conversion worksheet. That is your next assignment. Okay, have a great day.